Bro, you know what we need?
What do we need? What do we need?
A shot of grapefruit juice, bro.
Yeah, we need a shot of grapefruit juice, yeah.
Juicing the one and only ECE 3140 automated juice mixer.
Juice shot mode activated. Juice shot mode activated again. Juice shot mode activated again. Juice shot mode activated again.
That was so cool. You know what I think we even need that up? What? I reckon we try mixed juice. Mixed juice! Mixed juice!
Mixed juice mode activated with one shot of grapefruit juice.
Two-shot mode activated.
Juice mixer serving apple juice with 2 shots of grapefruit juice.
So what we have is the basis of the circuit is going to be this solderless breadboard, and then we also have the board connected to it. So on the board we have a couple pins going to the 5-volt in and the ground for the board to power it.
And they're color-coded, right?
Yes, of course. So those pins go down to this entire length of the power lines. So switches and stuff will be digital data into the board, and then these 2 wires right here are digital data out, which react with the transistor to power the motors.
And we got 2 of those, right?
Yes, so we have 2 motors and 2 transistors. So these transistors will act like a switch between the 5-volt main power and the power that's going to control the motors.
Oh, so in that way we can like activate the motors using the board, even though it doesn't have enough power.
Exactly. So the board doesn't have enough power to power these motors, but if we use these transistors, we're able to act basically like a switch and power the motors only when a digital signal 1 is written out on.
Why do we have potentiometers here?
So we don't actually use potentiometers for an analog input, but we found that we needed a pull-up resistor to use with the board to make the switches work and not have a faulty connection.
Ah, okay, so the potentiometers are like variable resistors. Very cool.
We have switches for the strength of the mixed juice drink. We have a button that will start the mixed juice drink, and then we also have a juice shot mode.
We made use of abstraction to ensure that everything was easy to understand and split into various functions. First, we defined the constants for all the pins on port B, including the mixer start button, the strength switch, the shot start button, both pump activators, and the LEDs. Next step, we initialize everything by enabling the clock to port B, setting up all the pins as GPIO, and setting the data direction of output for pumps and LEDs, as well as setting the data direction for input for the buttons and switches. Initially, the lights are set to off. Next, we have functions to turn green and red off, remembering these are active low. Then we have code to turn on and off input pump pins, these are active high. We also have read input pin to read any digital pin on port B. Startup delays for juice to reach the end of the pump, big drink delays for the dominant juice in the mixer, and small drink delays for juice shots. These are all busy waits that were learned using our test pump time script. Main initializes all the pins used and then repeatedly checks for a new start button press. Start mixer press C and start shot press C count the number of times in a row that the mixer and shot button have been pressed respectively. We loop until one of the buttons has been pressed 4 times in a row. A button press is indicated by a low signal. If shot mode was pressed, we turn the pump 1 on and wait the sufficient delay before turning it off to pour a shot of juice. Otherwise, in mixer mode, we read the strength switch value and activate pump 1 for the corresponding amount of shots. Then we activate pump 0 for the dominant drink delay.
Thank you for watching.